Okay, so we are going to wrap up amino acids today, and we are going to use this as basically the end of new material for our first exam, which our first exam is a week from today. Um, on Monday, we will be reviewing for that first exam. I'll kind of be going over the high points, talking about, make sure that you are familiar with this. Um, and illustrating some more thoughts about, exam preparation. Um, One of the things that I apologize that I've fallen behind on is your practice exam. I'm writing that alongside your actual exam. And so I will be finished with that today. I will post an announcement whenever it is up. I've got some other things that I want to do to give you guys more review materials. I've got office hours today at 12:30 if anyone wants to join and they've got some questions. I'll also have office hours on Monday at 12:30. Um, but what we're going to do now is we're just going to go ahead and basically wrap up, or go through our conversation of amino acids part two. Um, as a first thing, though, I've got a poll question. This is a single letter code question. Which of these is a polar negative amino acid? Right now, okay. Um, it's trending in the correct direction. Remember, we have our polar amino acids and our non-polar amino acids. So those are our two big categories. Within those, underneath those umbrellas are aromatic amino acids. So some aromatics are polar, some are non-polar. And we'll release and reveal those today. Um, when it comes to classifying your polar amino or your non-polar amino acids or your polars and your polar positive, polar negative, your polar positive residues are lysine, arginine, and histidine. Those three, I want you to know. Your polar negatives are aspartic acid and glutamic acid. Now, aspartic acid, actually, I'll go ahead with glutamic acid has the single letter code of E. Does anyone remember the single letter code for our other polar negative amino acid? There's a little bit of a trend with these two. Chris, you're absolutely right. D. So aspartic acid is D, glutamic acid is E. I think it's helpful to kind of associate the letters and the pattern where they are in the period, or sorry, the pattern of where those two letters are in the alphabet, and then the fact that they're both acids. I'm going to go ahead and end the poll. We ultimately got to the correct answer, where 41% of you guys said D is the correct answer. So you're absolutely right. If you remember, I wanted you to know basically kind of going back and forth between single letter and three-letter codes for your polar positive and polar negative residues. In addition to the single and three-letter codes, I also want you to be able to identify those amino acids. The others, they're kind of I'm not so concerned that you could identify glycine over alanine, but those polar positive and polar negative, those are the ones that I want you to be most familiar with. So those five are the kind of like peak of it all. Okay. So amino acids, day two. Whenever I talk about amino acids and share amino acids, I always like to show this because this is all of our proteinogenic amino acids. All of these amino acids are used to synthesize a protein. Now, are there any names on here that anyone recognizes? In particular, I'm thinking if you maybe if you take a pre-workout supplement or something like that. One that I can think of that is in uh so there are a couple that are in lots of pre-workout supplements. There's beta alanine is one. And that is similar. It's not the alanine that we're worried about. The alanine that we're talking about here would be alpha alanine. Phenylalanine, that is in your artificial sweeteners. Phenylalanine is a part of an artificial sweetener. Um, then another one that if anyone's ever eaten turkey, this is the one that kind of has a reputation for making you tired. Tryptophan. And now you don't have to keep this in as a part of your memory or anything like that, but look at tryptophan for a second, and then if you can, visualize it and rotate it like 90 degrees. And rotate it 90 degrees this way. There's the arrow. Tryptophan, like all of our other amino acids, has a single letter code. The single letter code for it is W. And the W, remember the rules for where the letters came from? Tryptophan's W comes from the phonetic pronunciation. In the event that you're like saying it with your tongue, you'd say twip, twip, tryptophan. But also one of the things that I always remember is that it kind of has like a W shape to it. It has two rings that, boom. And anytime I draw that, I've gotten the response of like, that's a W to you? Which I would say, yeah, kind of close. So anyway, but that's not one that I want you to kind of commit to memory or anything like that. So when you see this, it's a little bit overwhelming because what do I do with all this information? It's a lot of different molecules. And like I've told you guys what I want you to know. And so I always think that it's easier to take these 20 molecules and break them down into two major groups. Those major groups are, mouse, are you working? Uh-oh. It'll be a short lecture if I can't use my mouse. What's going on here? It's gonna be a short day of using my computer if I can't use my mouse. I'm saying all that because I'm optimistic that my mouse will come back. Oh, there we go. And now it's gonna have a backlog of like 14 different keystrokes where it just like slides me ahead 40 slides. But when that happens, we'll deal with it. So your two major groups are polar and nonpolar. Now, those two groups you can break down a little bit further. But everything underneath those, so think about this as every amino acid is either polar or nonpolar. Can you classify them a little bit more? Absolutely. How can you classify them a little bit more? Well, you could go into what we were talking about the other day, and where we classified things as, okay, just a second, y'all. I'm sorry, my computer is on the fritz, so I got to stop my share. We'll kind of keep talking, but we can classify those molecules that are initially classified as polar or nonpolar. We can do kind of a subclassification or a subcategorization. We can say, all right, well, lysine, histidine, and arginine are simultaneously polar, but they're also polar positive. Whenever we think about those, yes, they're polar and they're positive. We also have tryptophan and phenylalanine. Those are both, well, nonpolar, but they're also aromatic. So tryptophan is an aromatic amino acid. Yes. Tryptophan is also a nonpolar amino acid. Okay, I'm sorry, everyone. Can you guys see my screen all right? Can I get some response in the chat? Because that was very disruptive. I apologize for that. I had a background function going that, okay. So whenever you're asked, like, how are amino acids categorized? You start out with polar, nonpolar. Then you can look at each one of those groups. We did that the other day, and we particularly tackled our positive and negative residues. and that word residue, it's kind of a replacement word for amino acid, kind of individual component. Now, another thing that I want to point out to all these amino acids, or to you guys about all these amino acids, is when you look at the side chains, when you look at the R groups, and remember our R groups, we have our backbone, which consists of N, C, C. So we have our OOH, and then this other carbon. What was that carbon commonly known as that I just drew the hydrogen on? Our alpha carbon. Perfect. So from our alpha carbon, that's where our side chain comes from. A side chain is, what's a side chain also known as? I'll give you a hint. It's a letter group. An R group. Perfect. Okay, so that's where our R groups are. Great job. Now, when you're kind of scanning these, and I'm going to zoom in a little bit so maybe you guys can see a little bit better. Am I playing with fire by trying this right now? Maybe I am. Okay, there we go. When you look at these different R groups, and yeah, we're super zoomed in, and I'm going to scan over them kind of slowly and gradually. These are our non-polar amino acids. Lots of carbons, lots of hydrogens on those R groups. Does anyone see an atom here that one of these that's not like the other on those R groups and are those side chains? S. What is S on the periodic table? Sulfur. Perfect. Okay. So this is an amino acid known as methionine. Methionine is a nonpolar amino acid. The reason that you would look at this, or that I want you to look at this and say that this is a nonpolar amino acid, is because we've got a sulfur that's kind of blocked between a carbon and then another carbon. So although sulfur itself would make something polar, this CH3 at the very bottom, this methyl group, basically makes it nonpolar and basically blocks it. Now, I bring that up because, actually, I'll circle that, because I'm going to circle this amino acid. And then I'm going to zoom in on it. Well, I was planning on zooming in on it. That other amino acid is cysteine. So there are two amino acids that have sulfur in their side chains. Everything else has nitrogen, carbon, hydrogen, or oxygen. When you see sulfur and you see a methyl group, you're looking at methionine. When you see sulfur, and it's hard to see, and I apologize for that, but that's a sulfur, and then that would be a hydrogen right next to it. That is known as a thiol group. A thiol, and if you look at the periodic table, if you have a periodic table nearby, and I think I've got one too. Yeah, I've got one. Just a second. Put it in here for a reason. Go. Looking at the periodic table there, there's oxygen. What is right below it? Sulfur. Perfect. The element right below oxygen on the periodic table is sulfur. Now, elements that are in the same row on the periodic table, what we know about them is that they have similar properties. So if something has an OH group, like tyrosine here, you'd think, okay, that's a polar group. You should think kind of the same thing when it comes to an SH. SH indicates that that group is polar because it's going to have some lone pairs of electrons. It's got a pole to it. Okay, so that's one other kind of little factoid anecdote that I want you to remember is that sulfur is found in cysteine and methionine. Cysteine, or if you see sulfur, I don't want you, sorry, if you see sulfur, I want you to think, okay, well, it's probably going to be a polar group, unless whatever it's attached to is more non-polar, like a methyl group there. Now, I'm going to move ahead. Our negative amino acids, our polar negative amino acids, aspartic acid, glutamic acid. The single letter codes for aspartic acid, D and E, respectively. The three-letter code, ASP and GLU. Our positive amino acids, arginine, our pirate's favorite amino acid, ARG. Histidine has a single letter code of H, and HIS is the three-letter code. Lysine is K and has a three-letter code of LYS. Now, like I said the other day, those three-letter and one-letter codes, here they are again, but oopsies, this is where I did not make that correction. Tryptophan is TRP. The person responsible for that is Margaret Oakley Dayhoff. She studied biophysics and bioinformatics back in the 1950s until the end of her career, which is in the, I believe, the early 80s. And she passed away not too long ago. I think it was in late 90s or early 2000s that she passed away. But it was her work that led to the development of, well, let's use single letter and three-letter codes. Now, knowing these polar positive and polar negative amino acids is valuable because we will later talk about how amino acids interact with one another. And they interact with one another at the protein level where these two R groups or these two groups will interact with one another. A positive group is going to want to interact with a, what do you think, negative group? Absolutely. Non-polar amino acids? Well, for almost all of them, their side chains are kind of boring. The only one that's a little bit interesting is, and the one that stands out, is this guy right here, proline. Proline is the only amino acid that has an R group that kind of circles back in on its N termini, on the basically the end of its backbone. All the other amino acids, well, they're just putting out their side chains and they will interact or they will not interact with something. Now, these non-polar amino acids, whenever we talk about them in proteins, they are going to hate water because they're going to be pretty insoluble. Because if you remember from 1310, one of the phrases that we used with respect to solubility and if something dissolves, well, we talked about like dissolves like. Now, our polar amino acids, there's positive, negative residues, and then there's our polar uncharged residues. The ones that I want you to know best or be most familiar with. Yes, Stanley, absolutely. Non-polar groups are hydrophobic. They hate water. Or maybe they're scared of water. Or maybe I shouldn't personify something like that because it's not a person. And I'm speaking on their behalf. One of the important parts about today that I wanted you to get after and understand was this next slide right here. Peptide bonds and peptide formation. Okay, has anyone ever heard of a peptide or peptides, I guess? Okay. If anyone would care to share where they've heard of them, by all means, if you don't know, then that's fine. One place that you maybe have heard of them is collagen peptides. So if you go to like Costco or something, Vital Proteins is one of the brands. Oh, perfect, Caitlin. Yeah. Peptides are basically short proteins or they're short chunks. So it's a bunch of amino acids assembled. And they're in skincare. There's dietary, like I said, dietary collagen peptides. One thing that's becoming a little bit more popular, I guess, is injectable peptides. These are injectable peptides are things that people take for like bodybuilding or something like that. Um, to my knowledge, many of them are illegal, um, but people are getting them online. And I'm not sure about the safety. I can't speak to that, but I think that, whenever I think of injecting something, I'm like, doctor probably needs to do that, or a doctor needs to tell me how to do that. And I think that many of the injectable peptides are kind of like, you know, people who work out a lot will be like, oh man, I'm tired. I don't want to take steroids. I don't want to take an anabolic steroid. Oh, but there's this peptide. Ooh, I could take that peptide. Um, to me, they're kind of the same, but that's my own bias. So I apologize for, bringing that into the equation. Um, but peptides, that term peptide is really just the bond. It's a type of bond, and a peptide is also a assembled series of amino acids. So we've been talking about individual amino acids like alanine, arginine, and we use those one-letter codes and three-letter codes. Where those one-letter codes and three-letter codes come into being very valuable and important is when we talk about, making something out of 75 amino acids. We would have that backbone, N, C, C. Think about this as one amino acid. I'm going to say AA sub 1. That sub is just the subscript, AA1. Then we got N, C, C. This is our second amino acid, AA2. Then N, C, C. That is amino acid 3. Now, these are amino acids. And if we're assembling this into, 75 amino acids or 100 amino acids, drawing this out, writing this all out, it's going to take some time. Now, this right here is the peptide bond. So too is this. This entire thing right here is, well, it's 3 amino acids. This is going to be commonly known as a peptide. You might also see this referred to as a tripeptide. Now that seems a little bit confusing. The tri, TRI, indicates the number of amino acids. And the peptide simply means, well, the type of molecule that it is. 3 amino acids make up this peptide. Now, when it comes to the formation of a peptide bond, when you think about the NCC plus NCC, well, the C and the N of 2 amino acids will react, and they will produce water, and they will also make our peptide bond. Now, what I want you guys to know about this, and this will be helpful on your worksheet, one of your worksheets for this week, is being able to look at a peptide bond and, first of all, determine that, well, is it a dipeptide, a tripeptide? And, identify different parts of it. So this is an example of how peptide bond formation takes place. And this would be an example of a tripeptide. So that NCC backbone. Now, there's a couple of things that are important about a peptide. One thing is the N termini and the C termini. So when it comes to identifying what's known as the N termini or the C termini, I'm going to give you two labels, A or B. State in the chat, which do you think is the N termini? The thing that I've labeled A or B. Okay, I've got kind of a mixed bag there. And the correct answer for this is A. The reason that I want you to think about it as A is because where is there a free nitrogen? And what I mean by that is, yeah, this nitrogen, it's got this going on, H, H, H plus, but that nitrogen is not involved in a peptide bond. So then this B, well, where I just labeled that B, this is known as your C termini. Okay. Now, another thing that I want you to be able to do is identify peptide bonds. Now, a model like this, well, we kind of put it together, and at the moment it's still labeled. In just a little while, I'm going to show you some other models that are worthwhile to put together. Now, we're going to jump ahead. There's an example. And we're actually not going to be focused on ionization. Sorry about that. But this peptide right here is YE. Okay. So which peptide or which amino acid is the N-terminal amino acid? Y. Absolutely. Now, when you look at this, one of the questions that I might give you on an exam would be something like, here's some, I mentioned that you'll have some multiple select questions. Select the true statements. Okay, so I'll give you 4 statements. This peptide has cysteine. Okay. This peptide, I'm just going to say, has an aromatic AA, has a negative AA, and then last but not least, let's go with has a nonpolar or an NP AA. Now, I mentioned when we look back and did this kind of by design, when we go back and look at all of our amino acids, I've got tryptophan and phenylalanine in this aromatic grouping. But let's take a minute and look at tyrosine here. Tyrosine is our amino acid with with a single letter code of Y and a 3-letter code of TYR. Now it's hard to see here, but I'm going to zoom in. This slide is just, these are giving me fits, I guess. I'm going to forget that and just go back to where I was. I think Pictures must be too high resolution or something. Kind of a dumb humble brag. Because now I'm talking, the Zoom is working, but these pictures are giving me problems. So, and back to this. I'm going to go back to my model. Okay. So this would be a good example of a multiple select question. I give you a dipeptide because we got 2 amino acids, 1 peptide bond. This peptide has cysteine. True or false? Pretty false. Okay. Has an aromatic amino acid. Okay, well, that's kind of tricky. Chris, you're going with true. I like it. You're absolutely right. Because what do we know about an aromatic molecule? Alternating the ring structure with alternating double bonds. Chris, awesome. Perfect. Great. So this is an aromatic amino acid. Tyrosine is a polar and aromatic amino acid. So I'm going to say polar aromatic. Now, if you're thinking to yourself, but you said we didn't have to know the structure of aromatics. Yes, this is not a question that would make it past my filter. So this specific question would not appear on your exam. I've kind of given you the range of the questions that I'll ask regarding amino acid structures and codes and everything like that. But since we're working on this together, we would say, yes, this is an aromatic amino acid. It has an aromatic amino acid. The next prompt is, has a negative amino acid. True or false? True. Absolutely right, Chris. And then last but not least, has a non-polar amino acid. We're going to go with false on that one because non-polar tyrosine, which we have here, is a polar, and then E is going to be a polar negative. So we don't have a non-polar residue there. So these two that I put the X's through are the correct of our 4 possible answer options. Does everyone follow that process? Just as like a hypothetical example question. Okay, cool. Now, the questions that, or the next thing that I wanted to show you guys, I posted the link for this the other day. And I'm going to give you a kind of an example sort of question that you might see and what it would look like. And, some of the... Okay. So this web page right here, PepDraw. I shared the link on our Canvas page the other day, and it's a good one because it allows you to type in a amino acid sequence, and then it will draw that peptide for you. The one thing that you have to do for our purposes in this class is you have to take this pH and adjust it down to 1. And we're doing that just because of the kind of the way that we're talking about our amino acids and how we draw them and look at them. Everything else you don't have to worry about. But this will be helpful when it comes to the the worksheet that relates to amino acids and peptides. Is there a peptide for all the codes like the ones for amino acids last class? There is not a chart. For peptides, no, because peptides can be any number of different things. And what I mean by that is, if I were to, let's say, KR, let me zoom in a little bit. I'm going to type in a sequence of an amino acid. Can you tell me in the chat, KRDE? There we go. We got our single letter codes that I'm typing in, KRDE. These are single letter codes for our amino acids. Are these 4 amino acid single letter codes that are you guys are expected to know? These 4 specific ones. Yes, all these are. Okay. Now I'm going to click draw peptide. And it's going to come up with my structure. When you look at a molecule like this, it might be a little bit intimidating to know where to start. Now, my recommendation is that what we need to do is we need to be able to identify a couple of things. So what I want you guys to be able to do is go between a structure like this right here and 3-letter code, or I can draw an arrow there, so I will get 1-letter code. So go between, let me erase this right here. Be able to go between the 3-letter code and the structure, and the 1-letter code and the structure, and vice versa. Okay. So if you're looking at this, and I know anytime I see a structure like this, it's always pretty intimidating. But what we need to do is we need to think about, well, what are the letters that constitute our amino acid backbone? NCC. Now, when we look at, let's say that hypothetically you do not know KRDE. I haven't given you that. So I'm going to scribble this out. Actually, I'm going to get the box function and block all this information out. I want you to be able to look at this peptide and say and answer the questions, which is the C-terminal peptide or C-terminal amino acid, N-terminal amino acid. And if I might ask, I might circle something right here, and then right here, and then let's go with here. Actually, not that one. Here, here. And then I'll label them. A, B, C, D. Identify side chains. 4, identify peptide bonds. Okay. So if I give you a structure of a molecule like I've got right here, let's go through each of these questions, each of these hypothetical questions. And I'm going to switch colors to, I'm going to go with blue, a dark blue. And I'm going to mark up this molecule. Before we address the first or second question, what I want to do is I want to basically draw a dot on each of the atoms that make up my backbone of each amino acid and my backbone of my overall peptide. Can I get a thumbs up or a yes if, okay, I follow? Okay, great. So whenever I look at an amino acid or a peptide, I have this NCC kind of built in. That's what I'm looking for. I read a peptide left to right, but opposite way that I read the alphabet because I'm going from N to C as opposed to C to N. So here's my N. Here's my first C. Then here's my second C. Okay, is everyone good with that so far? Can I get a thumbs up, a yes, something in the chat? Okay. Now, after that, wonderful. I've got my next N right there. My next C and my next C. What do you guys notice about the second C's that I'm putting my dots on? What do they all have? Or what do they have of the two that we've looked at so far? They are carbonyl carbons. You're absolutely right, Chris. Great job. You might have forgotten that term, but it's got a double bonded oxygen. Okay. After that, I'm going on. So I basically wrapped up two of my amino acid backbones. So now I'm going on to N, C, C, N, C, C. Okay. So there are the four backbones for my complete peptide backbone. Now, what I am looking for is which amino acid, and I'm going to go ahead and do this I'll do this in orange. I'm going to circle, let's say, the side chain of my C-terminal amino acid. Okay, so I'm going to put a star by my C-terminal, my C-termini of my peptide. When I'm looking for my side chain, and whenever I look at any amino acid, what I'm looking for is, well, first of all, the absolute end of my C-termini has my COOH. So that's this atom right here. Then if that is that atom right there, what do we call that carbon right there commonly? It's not the carbonyl, and I know that was for your previous comment, but yes, Chris, again, you're right. The alpha, Javier, great. It's the alpha carbon. What do we know that our alpha carbon always has? It's got a single atom. Does anyone remember what that single atom is? It's got a hydrogen. Perfect, Chris. But what does it also have? It's also got our R group. So there's our R group. I just circled in orange the R group of our C-terminal amino acid. Can I get a thumbs up or a something in the chat if, okay, cool, I got it. Or if anyone has a question, please. Okay, we got thumbs up there. Thanks. Okay, great. Now, the next one is, well, circle the N-terminal R group. And for that, I'm going to switch to green. So I'm going to go ahead and color this green. And actually, I'm going to give myself a little color indicator here. So I've got orange for my C-terminal R group. My N-terminal, well, I start at my my N termini of my N terminal. Then I go to my first alpha carbon, which I've underlined in green. And I'm just going to take that underline and make it a complete circle. Done. There is the R group or the side chain of my N-terminal amino acid. So if you had a question that was circle or identify which of the circled groups is your R group of your N-terminal or C-terminal, that's what that's looking for. Now, a next level sort of question goes on to say, all right, well, what's the sequence of this peptide? And this is where it gets kind of hairy. And, I kind of think back and I'm like, oh, rats, what did I type in? I can't remember. But we can work through this because this particular peptide only uses positively and negatively charged amino acids. Because I did it like that because I wanted you guys to have a sense of this might be the sort of question that we would see or something similar to this. So whenever I look at this R group that's kind of long and it's got a nitrogen with a positive charge at the end of it, it's kind of lanky with a positive charge. That is going to be my K or lysine. Whenever I think about my positively charged residues, I've got my histidine ring. I'll write these out. And notice how I'm just saying positive or negative. I'm not saying polar positive or polar negative just because of the fact that, well, there's not a non-polar positive or anything like that. Okay, so positive, H for HIS, that's a ring. K or LYS, that's long plus nitrogen, a positive nitrogen. Then R or ARG is, well, the way I remember arginine, it's got 3 N's with a positive charge there. It doesn't have 3 positive nitrogens, but there are 3 nitrogens in that side chain or in that R group. So then my negative residues, well, it's D and E. They both have COOH, and E is, I'll just say longer. Okay. Now, when we look at that and we use that kind of as our guide, well, then this next R group is, it's positive. It's not lysine because we've already accounted for that. It's not a ring, so it is arginine. The last 2 groups, we've got, I'm going to use my alpha carbon and do the comparison that way. I've got 1 and then 1 carbon, this little edge there, that indicates 1 carbon or 1 CH2, and then this right here is COOH. My last amino acid, so I'm going to circle this R group. My last R group, which is already circled in orange, is 1 carbon, 2 carbons, and then COOH. Well, if I use the standard of glutamic acid is longer than aspartic acid, well, then this right here is E, and this right here is D. So constructing a sequence based on that will be helpful. Now, that would be one good question. The last one would be identify the peptide bonds. So this question would be something that would be like, all right, well, you have a couple of different groups that are circled. Which one of them is a peptide bond? Well, what do we know about a peptide bond? If we use NCC, NCC, C. The bond that connects a carbon and a nitrogen. So reading carbon to nitrogen, the bond that goes carbon to nitrogen, that carbon has a carbonyl oxygen. The nitrogen has a hydrogen. This, like this right here, is the peptide bond. Now, looking at this kind of skeletal structure is a little bit tricky. I'm going to screenshot things that I've already drawn on here, throw that into a Word doc so that I can post that to our Canvas page and nobody has to worry about, or nobody has to, yeah, because I'm about to erase stuff. And erase some of the markings. All of the markings except for the red letters and the red circles, just so it's a little bit less hairy. And then some of the blues I got to leave behind. Okay, so we've got a total of 4 different answer options. We've got A, B, C, and D. If we look at the bond that is circled and labeled A, well, let's see, what is that? That one is actually, I'm going to put a little star by it on that visual. That's a carbon to carbon bond. The bond that is circled, raise your hand if you think it's B. Yes, I know I can't see you, but okay, good. Happy that some of you raised your hands. Not really. None of you raised your hands. I know that. Because you knew that that was not a peptide bond. C. Also, well, that's a carbon to nitrogen bond, but that is not a peptide bond. Because if you look closely, this carbon isn't a carbonyl. There's no carbonyl there. Next up and last up is option D. Okay, what are we looking for? Well, we're looking for a carbonyl, carbon, and an NH. Brooks, thank you. You're absolutely right. So D is our peptide bond. Okay, so now I would like to kind of open the floor for any questions. But before, or sorry, as kind of a, exploring questions and thinking about things, this tool right here, pepdraw.com, will be very valuable because if you want, I'm going to clear all my drawings now. Actually, I'll pause. I'll give a little bit of time for anyone to ask any questions to the chat or unmute yourself and ask. In the diagram. Ooh, Chris, Chris, that is a fantastic question. In the diagram, that is to just make it appear a little bit more like favorable to look at. I'm inspired by your question because you're bringing up an extremely important point. Molecules and life doesn't exist on an X and Y axis. Instead, it exists in 3 dimensions. So proteins and peptides, they do this thing called folding. So those groups, the R groups, yeah, they're going to try to stay as far away from one another as possible because what they will do is they will kind of repel one another. It's a phenomenon known as steric hindrance. They will repel one another and stay away from one another. So to answer your question, yes, it is. So it looks less cluttered, but it is also a pretty reasonable representation of what a molecule is going to look like. That's a fantastic question. I mean, like gold stars, pats on the back all around. That's great. Okay, now I have a question from one of the homeworks. Benzene has a ring with hydrogens connected, C6H6. And phenol, I believe, has C6H6O6 on the ring for phenol, but it basically gets rid of the hydrogens. Please. Totally. Um, okay, let me just 1 second, Brooks. I'm going to come back to your question. What I want to do is just clear all my markings on the screen and then make my recommendation. And Marcus, I'll get to yours in just a second. So when you see this tool, what I would recommend doing is plugging in single letter codes. Draw the peptide and familiarize yourself with what that looks like. Because what I will do on the exam or for the exam is I'll just do print screen and use the snap it tool and just grab that. And you might look at this and say, oh, well, which one is the C termini? Which one is the R group? Well, the easy way to do that is to account for all the atoms that make up the backbone. Our backbone is NCC. Well, I put a second check mark there. How did I know that that third check mark was the C termini? Well, because I know the pattern of NCC. If I had tried to go in another direction, NCC, C, well, that would really be my NCC pattern to get my amino to my carboxylic acid. So my recommendation for this is to do short peptides. Type in a short peptide, see what it looks like. This information that I'm going to put a box around, you don't need to worry about this. The only thing that you need to do whenever you come to this so that you're looking at something that's similar to what you'll see on your exam is change the pH to 1. Change the pH to 1. That one detail is what you need to do whenever you start kind of like playing around with these questions. And so go ahead and plug in things like DRE. What does that look like? Boom, done. RER. What does that look like? There we go. That's what that peptide looks like. What sort of peptides are you going to see on your exam? Probably something that's no longer than 6 amino acids, 5 amino acids. So you should expect something like RR, BDR. That's arginine, arginine, aspartic acid, arginine. Okay. Now, with that in mind, that's where I'm going to stop for today. And that's where I'm going to stop for your exam. So for those of you who are going to head on out, have a great day. I'm going to stay around and answer a couple of questions. I'll keep this recording going just because it's kind of a part of the class. And then in just a second. So my first question, but anyway, have a great weekend. If anything comes up, I've got office hours starting in 30 minutes. We're cutting out a little bit early. But okay. Okay. If you want to meet tomorrow, if you want to meet Friday, tomorrow I'm going to one of my kids' schools to eat lunch with them. And that's around noonish. But then on Friday, I should have pretty open availability because I don't have a faculty meeting. Just shoot me an email. I'd love to help out. I'd love to meet. And like I said, Monday we've got a review, and then on Wednesday is our exam. And I'll talk more about the exam on Monday. For instance, it's during our class period. That's one question that folks always have. But we'll get there. Okay, I understand. And whenever I post more review content for you, I think that will help clear up like where do I start. And then I'm also going to get all of the Zoom questions and all your quiz questions. Look back at those because that's a good place. And another thing to remember is that this exam covers a lot of material. You're not going to show up and you're going to have 40 questions about peptides. So great question I got in a private message. Will we have to draw formulas or just identify? Just identify. I think that drawing things is worthwhile, so that's why I include it in like activities and worksheets. But I think that it's worthwhile in the sense that you're like, you know, wiring two things together, the physical and the mental thing. And that's pretty much the extent of my knowledge of neurology. Okay, so I'm gonna go back, scroll up. Brooks had a question. I have a question from one of the homeworks. Benzene has a ring with hydrogens connected C6H6. And phenol, I believe, is C6H6O6. And on the ring for phenol, it basically gets rid of the hydrogens and replaces it with OH. Can you explain that? Um, so sorry if it doesn't make sense then. Okay, so let me, if it's not, I'm just going to go ahead and draw here. Um, and I always like to take the structural formula or the skeletal formula and kind of translate it out. Just so that, honestly, that helps me keep track of all of my atoms. So I know that I've got OH here. So I know that each one of my carbons needs to have 4 bonds. And I know that my oxygen likes to have 2 bonds. So my oxygen is good. And in just a moment, I'll come back and check everything off. So my carbon, where my oxygen is, I know that that's got to have a hydrogen. Then this guy, I'm going to put, well, just a second. Before I do all that, I know the next thing that I need to do, and I'm going to change colors for this, is I'm going to put my double bonds in. Here's one, here's one, here's one. Now, this is just one example of what phenol looks like. Keep in mind that, well, we like that circle in the middle of the structure because, well, that's more realistic for what it looks like in terms of where the double bonds are. Okay, so what I've got here is I'm going to put a check mark by each of my atoms that has the right number of electrons or bonds to it. Hydrogen's good. This oxygen, I'm going to kind of fill in. This oxygen has 1, 2, 1, 2. So it has lone pairs of electrons. Then so that oxygen is good. Check. This carbon going down. Well, it's got 1, 2 bonds to the left of it, 1 above and 1 to the right. So that's good. Now my next carbon is 1, 2, 3 bonds. It is not good. And basically all the rest of them are no good. Now, with that in mind, we've got this carbon to the right. Got hydrogen. This has a hydrogen, 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 hydrogen. Okay, so now I've accounted for everything because I've got my benzene ring. I'm going to go back and get my check mark. Good, 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 good. Okay, so now if I write my formula, I've got 6 hydrogens. 1, 2, 3, 4, 5, 6. C6, C6H5 OH. So did I have it written as C6H6OH? If I did, I was incorrect there. Okay, I need to change that. Thank you very much. Okay. Take your time. Take your time. Okay. I got a private message that I'm responding to. Take your time. Okay. Okay, sounds great. I'll look forward to that. Then I had another question that was okay. So Brooks, are you good? Okay, cool. My next question was, can I go over how I determine the C termini and N termini? Absolutely. So if it's all right, I'm going to go ahead and, is that considered structural or formula? I think if Um, the lone pairs are sometimes, I got a private message that is considered the structural formula, right? I think I drew the right formula, but put the OH in the wrong place. The great thing about drawing phenol, there's no really wrong place to put the OH. I always put it at the 12 o'clock position, I think just out of habit. Um, and I think that that's probably pretty standard convention. But don't lose any sleep over it. Okay. The next thing that I'm going to do is I'm going to clear all my drawings. Done. I hope nobody needed that. And now what I want to do is I'm going to plug in a dipeptide. I'm going to do RK. So I'm plugging in the single letter codes for arginine and lysine. I'm going to draw this peptide. I'm going to scroll down. I'm going to zoom in a little bit. And now what I'm going to do is I'm going to again go through the exercise of putting little markings on each one of my atoms that make up my backbone. And what I like about PepDraw here is that basically your backbone is shown in the middle. So anything that's sticking up or sticking down, think about that as, aha, that's probably a good clue for being an R group. Now, that's my box around my backbone. But next, what I want to do is I want to circle the atoms that make up my backbone. N, C, C. So I got this N, C, C. That's my amino acid backbone. And then I can follow that with N, C, C. Again, here for my other amino acids backbone. So I've got my peptide backbone of NCC, NCC. Now, the next thing that I want to do after I erase those circles is I am going to get a yellow line or the yellow marker. And that yellow marker, what I'm going to do is I am going to draw my peptide bond. But before I do that, I'm going to take my written out NCC, NCC, and I remember, and this is an important thing to remember, that my peptide bond, I've got a carbonyl carbon and then a nitrogen with NH. Okay. Carbonyl carbon and NH, and this is that bond. So I'm going to kind of color code both of them as my peptide bond. Okay, now what I want to do with that is ask a question. This nitrogen right here that I just circled in red, add to the chat anyone if you want, is that nitrogen involved in a peptide bond? So basically, is it connected to a carbonyl carbon is my question. I'm happy that you want to say yes, because you're absolutely right. So the nitrogen that I've circled in red on my structural or my skeletal formula is this nitrogen right here. Because this yellow bond right there, or that yellow line, that's my peptide bond. Does that help illustrate it a little bit more? I'm going to draw my red line to the yellow line. Okay, great. Now, my next question is, I'll start broadly. In the underneath the word peptide or words peptide structure, do you see any other nitrogens? Does anyone see any other nitrogens? So underneath here, do we have other nitrogens? We do. Now, to narrow it in a little bit. And I'll go ahead and switch to green. I'm going to circle all my nitrogens. This one. Yeah, any nitrogens really. Just the N. I got this one, that one, the one that I already circled in red. Now I'm circling that in green, and then I got this one right here. Now, does anyone see any other nitrogens that I haven't circled in green? No, there aren't any others. You're right. Okay. Now, this box that I drew that's blue, what was that box again? That was my backbone. Okay. Now, how many or actually those backbone atoms are the only ones that matter when it comes to peptide bond identification and N and C termini identification. So any other nitrogens, I don't care about. Now, I see two nitrogens there, right? This is a dipeptide. Each amino acid has NCC. Now, whenever I look at these nitrogens that are inside my backbone box there, what I want you to look for to say the N termini is I want you to say, well, where is nitrogen that is not in a peptide bond? If you can answer that question. And, the way that we can answer that question is we've already identified one nitrogen that's in a peptide bond. And that would be the one that's circled in both green and red. So if you use, what's it called? Deductive reasoning, we've got two total nitrogens. One of them is in a peptide bond, and one of them's not. So would you agree, everyone, that this is the nitrogen that is not in our peptide bond? Perfect. So that nitrogen that is not a part of our peptide bond is the N termini. I'm just going to label it N term of peptide. And that would be corresponding to that nitrogen that I just put a dark blue star by. Okay, are we feeling good about this so far? Because if I get a yes or a thumbs up in the chat, then I'm going to go on to, all right, now circle the N-terminal R group. Okay, awesome. So now the question or the prompt would be, can you circle the N-terminal R group? And the way that we do that is we read in amino acids N to C. So left to right. Our directionality is opposite of the alphabet. So we're going N to C. So we go N to our first C, then to our next C. And the next C, what type of bond is that next C wrapped up in? Peptide. Perfect. So when we see that carbon that's wrapped up in the peptide, we say, oh, we've gone too far. We need the carbon that immediately follows the N-termini of that amino acid. So here's our nitrogen. And here I'm putting a box around. So now of my two models, They both have a box around our C, which what do we know that carbon as? It's commonly known as the blank carbon. And I'll give you a little bit of a hint. Think of fraternities and sororities. The alpha carbon, perfect. The much less popular fraternity, sorority, whatever, alpha carbon carbon. That doesn't exist. Alpha carbon alpha. There we go. That would be fun. That alpha carbon is where we find our R group. So if I asked you the question, circle or label the, or sorry, not label. If I had this circled and this was labeled A and this was labeled B, and then let's just for the sake of fun, I'll circle this C. If I said, oh, which of the following is your N-terminal R group? Answer that question for me. Is it A, B, or C? Or D, none of the above? A. Perfect. Perfect. Now, follow-up of that. What is B? Well, that could be asked a couple of different ways. It is the C terminal, the C term R group. What else is it? Well, identity-wise, when we have one single nitrogen out there, is it a histidine? No, it's not a histidine. It is a lysine. So you find the R group from the alpha carbon. Yes. Marcus, if I can, I feel like just from the questions you've been asking, I feel like you look at this very similar to how I look at this. And if I can be completely honest with you, the way that always helped me to figure this out, like the structure that I'm showing you, this underneath the words peptide structure, that's something that I would always take and I would just translate it out. I'd be like, okay, cool. I see a bunch of atoms there. The way that I approached that was I would say, that's, I had friends in classes who were like, oh yeah, I can read this structure right here, no problem. I didn't. I didn't work like that. My mind works like this. I got to write out NCC. As soon as I write out NCC and I remember I remember that it's nitrogen, alpha carbon, carbonyl, then I can circle things as kind of like landmarks almost. And be like, okay, cool. There's my carbonyl carbon. And I know after my carbonyl carbon, I've got a peptide bond. And then I've got NCC. And lo and behold, if this continues on, if it's like a 6 amino acid long peptide, I know nitrogen, alpha carbon, carbonyl, nitrogen, alpha carbon, carbonyl. Alpha carbon's got my R group. And so, just as a little bit of a, not warning, but a thought, I might give you a question that says, which of the following is actually, heck, we can use what I've got right here. I've got A, B, and C. Which of the following is not an amino acid R group? Well, A is, B is, C is not. Because C is just the termini or the C termini of my amino acid or of my peptide, sorry. So if it is at all helpful, you're going to have scratch paper on the exam. So take that peptide structure, that skeletal structure, and just translate it out. That always helped me because I have ADHD and the way that my brain works is like, okay, cool, nitrogen, boop, 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 boop. It was always very helpful for me to write it out because then I'm like pacing myself. I'm slowing myself down. I'm saying, okay, N, what's after N? Alpha carbon. What's after alpha carbon? Carbonyl. Does that help at all? Okay. Thanks for asking. If you got any other questions, just let me know. Have a good one. We're at 12:21. I'm going to go ahead and stop my recording. You guys are free to ask